you, my friends? This is lecture number 25 of the pre-calculus course, Basic Trigonometric Equations. I just want to mention here that lecture number 26, the one after this, will be more trigonometric equations, more difficult, more challenging, more interesting. Let's see here some hints or ideas I would like to present. It's very important here that you remember the special angles, 30, 60, 45, and their multiples, because you have to use the sine, cosine, tan, and cotan of these special angles. The signs, SIGN, of trigonometric functions, positive and negative functions in which quadrant. If the reference angle, we have to use the range of trigonometric functions and factoring sometimes. So these ideas will help you to solve the basic and also the other trigonometric equations. Let's see question number 1. We have two parts here. Solve the basic trigonometric equation. Part A, sine of x is equal half x between 0 and 2 pi. The second one, sine of x is equal half. Clearly here we see the first one has a condition. That means the solutions are limited. The second one, there is no condition, so we have to find all the angles x whose sine is half, and they are infinity. So the first one, we call it, there is a limited number of solutions because there is a condition here. So we ask two questions. We have the question, sine of x is equal half. We say sine is positive because half means plus half. The angles are in quadrant 1 and in quadrant 2, where sine is positive. Use the reference angle. Look at the value here, half. So x will be pi over 6. That's in quadrant 1. In quadrant 2, to find the angle, if we know the reference, it will be pi minus pi over 6, which is 5 pi over 6. So the solution set for this equation with this condition, two solutions, pi over 6 and 5 pi over 6. Let's see now the second one, where we have no condition, unlimited number of solutions. So sine of x is equal half. We need all the solutions here. So first, we find the solutions in one period. We know the period of the sine function is 2 pi. So from 0 to 2 pi, which is part 1 exactly, we find all the values of the x, which is pi over 6, 5 pi over 6. Now each one, we have to add 2k pi's. So the solution here, the all solutions, general solutions will be pi over 6 plus 2k pi and 5 pi over 6 plus 2k pi, where k is integer. So in this case, we have infinity of solutions. So we take these solutions in one period, and then we add 2k pi, where we find all the coterminal angles. Let's see more examples. Example 2 is two parts also. Tan squared of theta minus 3 is equal to 0. Tan squared of theta plus 3 is equal to 0. Now, if we look at the solution of part A, tan squared theta minus 3 is equal to 0, let's rearrange the equation. Take 3 on the other side and take the square root of both sides. So we get tan of theta is equal plus or minus square root of 3, and then we take each possibility alone. Now, I would like to mention here that you can factor this by difference between two squares if you like. It will be tan of theta minus square root of 3 bracket multiplied by another bracket, tan of theta plus square root of 3 is equal to 0. You will get the same answer. Now we have tan of theta is equal plus square root of 3. That means theta will be tan inverse square root of 3. We know the period for tangent function is pi, and the range of the inverse between minus pi over 2 to pi over 2. So the only theta we have here is in quadrant 1, which is theta equals pi over 3. Now let's consider the other possibility on the next slide. Tan of theta is equal minus square root of 3, so theta will be tan inverse of minus square root of 3. Again, we have to go to this condition, minus pi over 2 to pi over 2 open. We find 1 theta there in quadrant 4 minus pi over 3 belongs to quadrant 4. So now we can write all the solutions. Theta pi over 3 plus k pi, remember the period for tangent function is pi. And we have another theta minus pi over 3 plus k pi where k is integer. If we look at B part, tan squared of theta plus 3 is equal to 0 cannot be factored, because if we can take this on the other side here, tan squared of theta is equal minus 3. If you try to take the square root of both sides, it will be tan of theta plus or minus square root of minus 3. And this number is complex number. It's not a real number. So there is no theta and there is no solution for this equation. Example 3, we have another maybe easy equation. Sine of x plus square root of 2 is equal minus sine of x. Let's solve this equation. First, we have to rearrange it. So bring this minus sine x on the other side and add, becomes 2 sine of x. Take the square root on the other side, becomes a minus, divide by 2. Now, this is the important thing here. Sine of x is equal to this number, minus square root of 2 over 2. We have to ask two important questions. Which quadrant? We look at sine. Sine here minus. So sine is negative. See the quadrant 3 and 4. Because the sine is minus in 3 and 4. Now look at the value. This value, square root of 2 over 2. What is the reference angle? The answer, pi over 4. So from the last slide, we had sine of x is equal minus square root of 2 over 2, and the reference angle is pi over 4. So let's find the first angle in quadrant 3. We know in quadrant 3, the angle will be pi plus the reference, which is pi over 4. So it becomes 5 pi over 4. And in quadrant 4, the angle x will be 2 pi minus the reference. It will be 7 pi over 4. Now, in the given, there is no condition, which means we have unlimited solutions. So all the solutions we can write as x equals 5 pi over 4 plus 2k pi, because the period of sine is 2 pi, and x equals 7 pi over 4 plus 2k pi, where k is integer. Example 4 is important. Let's see the equation here. Sine squared of x plus sine of x is equal 1 plus 2 sine of x minus sine squared of x. That's the equation. It's very clearly that the equation is not arranged. Now we need to find two things. Find all the solutions of the equation without any condition you can see in part A. In part B, we need the sum of all the solutions in this given interval, closed 0 to 2 pi open. So first we rearrange the equation. You bring minus sine squared, becomes 2 sine squared of x minus sine of x minus 1 equals 0. Remember in the algebra course, in the factoring, you can let sine of x is equal capital M to make it easy, or you can directly factor this quadratic equation. Now we have 2m squared minus m minus 1. To factor this, you get 2m plus 1, m minus 1. Make sure the factoring is correct. So m will be minus half, or m will be 1. Now we know m is sine of x, so I write here sine of x is equal minus half, or m is minus 1, so sine of x will be 1. Let's look at this easy one. Sine of x is equal to 1. This is a quadrantal angle on the y-axis. And this x will be 90 degrees or pi over 2. Leave it. Let's go to this. Sine of x is equal minus half. We have to ask, remember, two questions. Look at the sign, the minus. Where's sign of minus? Quadrant 3 and quadrant 4. Now the value is half. So what is the reference? The reference will be pi over 6. So we have to find two angles in quadrant 3 and in quadrant 4. The reference is pi over 6. So the first angle will be x plus pi over 6 will be 7 pi over 6, and x will be 2 pi minus pi over 6, which is 11 pi over 6. So we write now all the general solution can be written as 7 pi over 6 plus 2k pi, and x equals 11 pi over 6 plus 2k pi, and remember x equals pi over 2 plus 2k pi, where k is integer. Now in the second one we need, so this is the general solution here, we can see that. Now solutions are needed in this given interval. So I can put k0, 7 pi over 6, 11 pi over 6, pi over 2. I can put also k equals 1. But remember, if I put here k1, the angle will be greater than 2 pi in each one. If I put k equals minus 1, it will be negative angle. So these are the only three angles or solutions or values of x in this interval. Please be careful here. You can put any k that will give you an angle in this interval. That's the condition. Let me show you the note here. If the given interval is changed, you can have 0 to 4 pi, 0 to 5 pi. All the solutions will be changed. So now we need the sum. Just add these three. Sometimes we ask find the number of solution. So the answer will be 3 in this case, in this interval. So 7 pi over 6, 11 pi over 6, pi over 2. Here we need the LCD multiplied by 3. Remember, up and down. So you have 3 pi. So that will be 21 pi over 6. When you simplify, you get 7 pi over 2 is the sum. Now this is a tricky question. Find the general solution in degrees of the trigonometric equation sine theta tan theta is equal sine theta. Just take a minute, please, if you want to try, then you can check the solution on the next slide. What do you think you can do? Maybe some might think of dividing both sides by sine of theta, and that will be wrong. Now, this is an important note. We cannot divide both sides by sine of theta because sine of theta is not constant. You can divide by 5, you can divide by 2, you can divide by -1, you can multiply by 6, but you cannot divide by variable here, sine of theta, because some solutions might be deleted or lost. So instead, what do? Just move it, rearrange it. You see, take sine theta on the other side equals 0, then we can factor sine of theta in the bracket, tan of theta -1. So each factor is equal to 0. We say sine of theta is equal to 0 or tan of theta is equal to 1. Now we see from last slide that sine theta is equal to 0 or tan theta is equal to 1. Let's look at all the angles in one period, 360 degrees, which is 2 pi, the period for sine, and 180 degrees or pi, the period for tan. So if sine theta is equal to 0, then the angle theta is 0 degrees and theta is equal to 180 degrees. These are called quadrantal angles. If tan theta is equal to 1, then theta is 45 degrees in quadrant 1. So we can write all the solutions as theta equals 0 degrees plus k times 360, and theta equals 180 degrees plus k times 360, and theta equals 45 degrees plus k times 180, which is pi, the period for tan. This is a nice question related to question number 5, if you can notice here. Given the trigonometric equation sine theta tan theta is equal to sine theta. Actually, it's the same question, right? Same question as example number 5. But what do we need here? Over the interval 0 to 200 degrees, find the solution set, which means find all the angles, the solution set, And then B part, find the number of solutions in this interval. See, we have specific interval here. So we can borrow the general solution from last example. See, that's the general solution from the last example. Now the solution is in the required interval, so we can put k equals 0, k equals 1, k equals 2, k equals 3, k equals -1. Choose any k you like, k is integer, but the condition is all the angles you take, you count, you use, should be between 0 closed to 200 open. Let's say k is 0 here, so the angle 0, angle 180, angle 45. Take k1, so this one will be 360, this one will be 540. If you put here k1, put here k1, theta will be 225. Just you can notice here 360, 540, 225, this is the second line. All these angles greater than 200, so we don't take. So for sure, if you take k equals 2, it will be more and more. If you take k equals -1, it will be all negative angles. So what are all the angles? The solution set will be 0, 180, 45. All these lie between 0 and 200. Second part, find the number of solutions, 3. Now let's solve the trigonometric equation. 2 sine x cosine x is equal to square root of 3 cosine of x. Very similar to example number 6. Very similar in the way that you cannot divide here by cosine of x. See, you cannot divide by cosine of x because you will lose some solutions. So instead we rearrange it, take all this on the other side, equal to 0, factor out the cosine of x, and remember here to write 2 sine of x minus square root of 3 is equal to 0. So we take cosine of x is equal to 0, or sine of x will be square root of 3 over 2. So from the last slide, we see that cosine of x is equal to 0, or sine of x is equal to square root of 3 over 2. We know that the period for sine and cosine is 2 pi. So let's look for all angles in the first period. So if cosine of x is equal to 0, then x will be pi over 2 and x will be 3 pi over 2. These are called quadrantal angles because they lie on either x-axis or y-axis. If sine of x is equal to square root of 3 over 2, then x will be pi over 3 and x will be 2 pi over 3. This is in quadrant 1 and quadrant 2. So the reference angle here is pi over 3. And remember, in quadrant 2, the angle itself will be pi minus the reference pi over 3. So the angle will be 2 pi over 3. Then we can write the general solutions. X equals pi over 2 plus 2k pi, and x equals 3 pi over 2 plus 2k pi, and x equals pi over 3 plus 2k pi, and x equals 2 pi over 3 plus 2k pi, where k is integer. Now let's look at example number 8, which is a more challenging equation. We have the equation here, 4 tan theta sine squared of theta minus 4 sine squared of theta is equal to tan theta minus 1. Let's find 3 things. Part A, find all the solutions of the equation. We need here the general solution because we have no condition. B part, find the number of solutions in the interval 0 to 2 pi. In the C part, find the sum of the solutions in the interval 0 to 2 pi, which means we find the solutions from 0 to 2 pi, then we add them. In P part, we need the number, we count the numbers only. Let's see, rearrange the equation. You can bring here tan of theta minus 1 on the other side, becomes minus tan theta plus 1. And we see here we have 4 terms, 1, 2, 3, and 4. So let's use grouping, factoring by grouping. You know that. Take first 2 terms, 4 sine squared of theta, then tan of theta minus 1. Here there's a common factor, only minus 1. In the bracket, we have tan of theta minus 1. Then we see this is a common factor again. Tan of theta minus 1 is in the common factor here. Then what's left inside is 4 sine squared of theta minus 1. We have seen this in the algebra course many, many times. Now, tan of theta is equal to 1, or 4 sine squared of theta is equal to 1. If you put this is equal to 0, this is equal to 0. Now, let's simplify more. Tan of theta is equal to 1, or divide by 4 and take the square root of both sides. So sine of theta will be plus or minus half. So we have here 3 possibilities. Tan of theta is 1, sine of theta is half, sine of theta is minus half. Let's continue on the next slide. Now, tan of theta is 1, that's easy. So the angle theta is in quadrant 1, and this angle is pi over 4. Finished. Sine of theta is equal plus half, and see the other one is minus half. So here we have to look at the sign, S-I-G-N, positive. See, positive, quadrant 1 and quadrant 2. And this is negative. Where sign is negative? Quadrant 3 and quadrant 4. So let's find the angle in each quadrant here, where sine of theta is plus half. So the value here is half. That means theta will be pi over 6. Or in quadrant 2, it will be the pi minus the reference, which is pi minus pi over 6, 5 pi over 6. Now here the reference also, pi over 6. In quadrant 3, it will be pi plus pi over 6, which is 7 pi over 6. And in quadrant 4, it will be 2 pi minus pi over 6. Now, so all the solutions, the general solution can be written as theta equals pi over 4 plus k pi. Remember here, the period for tan is pi. So we get that from this pi over 4. Then we have to use these angles here. And then we have to add 2k pi because the period for sine function is 2 pi. So we say theta equals pi over 6 plus 2k pi, and theta equals 5 pi over 6 plus 2k pi, theta equals 7 pi over 6 plus 2k pi, and theta equals 11 pi over 6 plus 2k pi, where k is integer. Now, in the B part, we need, in the interval here, the given interval 0 to 2 pi. So let's take k equals to 0. So this would be pi over 4. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. That's easy. Now, if I take k1, I put here 1. So it will be pi over 4 plus pi, which is 5 pi over 4. If I put here 1, it will be greater than 2 pi. Same for this one, same for this one, same for this one. So I cannot take k equals 1 in the other, these 4 parts, only in the first one, because the angles will be between 0 and 2 pi. So I have 1, 2, 3, 4, 5, 6 solutions, 6 angles, 6 theta values between 0 to 2 pi. In C part, we need the sum. So we have to add pi over 4 plus pi over 4, 5 pi over 4 plus all the other angles. Remember here, this is 4 and 4, and this is 6. Find the LCD or add any way you like. Please check the number. You will get 11 pi over 2 is the sum. Now, there are some questions here I will leave usually for you to practice. Old exam question number 1. Solve this equation 3 tan cubed of x is equal to tan of x. Another 1 tan of x cosine of x minus tan of x minus cosine of x plus 1 is equal to 0. Find all the solutions as we did before, and then find the sum in this interval. Find the sum of all the solutions of this trigonometric equation secant squared of theta minus 2 is equal to 0 in the interval 0 to 2 pi. Question number 4 is really interesting. Find the sum of all the solutions in degrees, please, of this equation tan of theta plus 1 is equal to square root of 3 plus square root of 3 cotan of theta in the interval 0 to 360. Find all the solutions of this equation. 2 cosecant of x cosine of x is equal cosecant of x in the interval 0 to 2 pi. And then question number 6 is close to question number 5, but not the same. 2 cosecant of x cosine of x minus cosecant of x is equal to 2 cosine of x minus 1. We need all the solutions, find them in the interval 0 to 2 pi. Now, as usual here, I put all the answers of all the parts in these 6 questions. For complete solutions, please, you can see the video on Basic Trigonometric Equations, lecture number 25, Pre-Calculus, all the exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is Pre-Calculus course, lecture number 25. I wish I can see you in another video with another topic. Thank you very much for listening.